In 1982, the Ocean Ranger was the undisputed heavyweight of offshore drilling. It was the largest semi-submersible rig in the world, a colossal structure built to dominate the harshest marine environments on Earth. This was a 25,000-ton fortress anchored to the seabed. Its designers engineered it to drill in water up to 3,000 feet deep, and its hull was built to shrug off steady 100-knot winds. When a brutal winter storm hit the Grand Banks off Newfoundland on February 14th, the rig faced winds of nearly 70 knots and towering 65-foot waves. The primary structure performed exactly as intended. Those massive steel support columns stood firm against the immense crushing force of the ocean. While the massive steel support columns were capable of holding the structure together, a microscopic vulnerability remained hidden within its design. When investigators surveyed the sunken wreckage at the bottom of the Atlantic, they found a baffling scene. The main structural framework of the rig was completely intact. The failure traced back to a single architectural decision. The ballast control room, the nervous system of the entire rig, was located in a corner column just 28 feet above the waterline. Its only defense against the North Atlantic was a set of standard tempered glass portlight windows. The world's largest marine structure, built to survive hurricane-force winds, was managed by a control center protected only by a single pane of glass. During the peak of the storm, a massive wave slammed against the column and smashed right through one of those portlights. Seawater immediately blasted into the dimly lit ballast control room, soaking the main control console. This console was never designed to be watertight. It used active 110-volt electrical circuits to trigger the compressed air valves that manage the rig's buoyancy down in the pontoons. As the salt water bridged the exposed contacts, it caused immediate short circuits. The indicator lights on the panel flashed red and green as the massive valves below started opening and closing completely on their own. Realizing the console was malfunctioning, the crew made the correct tactical decision and cut the main electrical power to the control panel to stop the erratic behavior. This action triggered the system's built-in fail-safe. Without electrical power, the control air automatically vented out of the lines, allowing heavy mechanical springs to release and forcefully push all the main ballast valves into a locked, closed position. At this exact moment, the fail-safe had worked perfectly. The rig was sealed. If the operators had simply stepped back and done nothing else, the Ocean Ranger would have safely ridden out the rest of the storm. But inside that control room was a set of brass actuating rods. These were manual override tools used for testing, and they had been left on board by mistake during the rig's construction phase. The crew was operating blind. They had no manuals for an electrical failure of this magnitude, and the operators had never received formal training on the intricacies of the ballast control system. Desperate to regain command of the rig, they grabbed the brass rods. Believing they were manually securing the system, the operators began inserting the brass rods into the control solenoids. By threading the brass rods inward, they were actually physically compressing the safety springs, completely overriding the fail-safe that was keeping them afloat. That action mechanically forced the massive sea chest valves wide open. They had just created a direct, unclosable path between the rig's internal tanks and the raging ocean outside, and gravity took over immediately. Thousands of tons of seawater rushed uncontrollably into the forward pontoon tanks, pulling the rig's bow down into the waves. The crew's desperate, uninformed attempt to save the rig was the exact trigger that sank it. It proved a hard truth. No matter how robust an engineering failsafe is, it is entirely useless if the people operating the system don't understand how it works. As the rig tilted forward, the internal pumps were simply too weak to push the encroaching water up against the severe angle of the list. The bow dipped lower and lower until the massive chain lockers at the corners submerged and flooded completely. An evacuation order was given, and all 84 men prepared to abandon the rig, but the evacuation hardware failed them. Because of the extreme forward tilt, the gravity-launched lifeboats suspended high above the churning water could not be deployed safely. A final operational failure left them with no backup plan. At the time, regulations did not require offshore crews to have thermal immersion suits. When the men entered the water, they were entirely defenseless against the freezing North Atlantic. The loss of 84 men revealed a systemic failure to balance structural endurance with the practical requirements of human survival. The loss of the Ocean Ranger triggered immediate sweeping architectural reforms. Global regulations now mandate that ballast control rooms be elevated far above wave height. Electrical systems must be fully waterproofed, and secondary independent backup controls are strictly required. Operations were overhauled just as severely. Today, there is a strict international mandate that every single offshore worker is equipped with their own immersion survival suit to protect them from exposure. The legacy of the Ocean Ranger is a permanent change in how engineers approach marine design. True safety requires building systems that account for human panic and prioritize user interface rather than relying solely on raw environmental brute force. End of report.